Hello everybody, welcome back. Um, and last time we looked at how to use the printf function to print or output some text and show it to a user. Today we're going to use another related function from the stdio header library, and we are going to use this function to take data as input from a user and then maybe play around with that data and do some mathematical operations on that data. Basically what we're going to do is we're going to take two numbers as input and then we're going to add them and then display the result on screen. So the function that we're going to use for this purpose again comes from the stdio header library, which is a collection of useful functions that allow us to input and output something from a computer. So the function we're going to use is going to be called or is referred to as the scanf function. So let's jump straight in. So this new function again on top has the stdio.h header preprocessor directive, and then new stuff in this code which you may not have seen before in the previous lecture is highlighted in yellow. What you can see at line 8 is we're first writing int, so we are declaring an integer variable. We're calling this variable integer 1. Then we are declaring another integer, we're calling it integer 2. And then you have a printf statement which asks the user enter first integer, and then you have the scanf function, and the scanf function obviously has its own format which we will discuss in a second. So the scanf here is basically, as is obvious from the comment, is used to read an integer. So in this case we're going to read an integer, but you can also use this scanf to read non-integer type of data. So you can use it to read in not just whole numbers, but you can use it to read in decimal numbers as well, and you can use it to read characters as well. So we input one integer, then we ask the user to input a second integer, and then in order to save the value or bring the value of the integer entered by the user into our program, we again use the scanf function, and then finally we declare a third integer which we are calling sum. And what that sum variable does is that it takes the two integers, integer 1 and integer 2, adds them together and stores the value. And then finally on line number 20 we use the printf statement to print the sum of the two integers, and then finally our program terminates as indicated by the curly braces here on line number 22. So now let's move ahead and look at each of these new concepts that we have examined in this program in a little bit more detail. So first let's look at the sample output of this program. So when it's run, let's say first thing that will happen is the first printf statement will cause this statement to be printed on screen. So it will say enter first integer, and then the cursor will go on to the next line. On the next line the user entered the number 45. Then the program will ask the user to enter another integer. In this case the user has entered 72. And then on the third line you see that the sum of these two integers is 117, and that is shown on the next line. And you can obviously verify to check if this is correct, but I'm pretty sure that this is correct. So that's what this program does. So even though again you see a lot of lines of code over here, what the user basically sees is just 3 or 4 lines, so he does not have to worry about all this stuff that you have put in here. Okay, so the first thing that we want to do is that if we want to play around with some numbers, if we want to do some sort of arithmetic operations or mathematical operations, we first have to declare some variables which we will use to store those numbers and which we will use to also do some mathematical operations on those numbers. So it's kind of similar to what you did in your maybe your maths or your algebra class, where let's just say you had 2 variables and you wanted to add them, then you could declare them as one variable as x, the other variable as y, and then you could store the result of sum of x and y into the variable z. So it's kind of like that. However, computers are generally not as smart as you guys, so when you're adding numbers with computers, you also have to specify in a lot of cases what sort of numbers do you want to add. So with a computer you have to also specify, okay, that this integer 1 variable is basically an integer variable. It can store values like -1, -2, 0, +1, 1000, so on and so forth, but it cannot store decimal numbers. So you have to tell the computer explicitly, if you're going to program in C, that you're going to be working with integers. So in this case, all 3 variables are integers, and so you're declaring them as integers. So first of all, before naming the variable, you have to tell the program what type of variable is it going to be. Okay. So all variables must be defined with a name. So yes, if you're going to define a variable in C language, you have to give it a name before they can be used in a program. One more statement that is important to remember is that instead of individually writing each variable on a separate line as you did in the previous example, what you can do is you can write them on the same line. So in this case you could have just written, in the previous program, even if you had written something like integer, so int integer 1 comma integer 2 comma sum followed by a semicolon, what this would imply is that, okay, in this program you're going to use 3 integer variables, integer 1, integer 2 and sum. So you did not have to write 3 separate lines of code in order to declare 3 integers. So one thing that they kind of highlight here is that they use 3 separate lines because after each line they kind of wrote some comments about this is integer 1, this is integer 2. So this was written just to make the code easier to read, but it does not have to be this way. Now one thing that you want to remember about naming variables is whenever you're naming variables in C, you have to follow certain rules. A variable name in C is any valid identifier. So what do we mean by an identifier? It's a series of characters that has to follow certain rules. And what are those rules? So if you are defining variables, one thing that you need to remember is that variables are case sensitive. So if you use the name A1 for a variable, and we're talking about A1 where the A is lowercase, and then you use another variable with a capital A which is A1, then these will be two distinct variables. So this one will be different from this one because C is case sensitive. So case sensitivity basically means that it will not consider these to be the same variables. Another thing that you want to remember is that an identifier can consist of letters, digits, and underscores that do not begin with a digit. So, you know, an identifier or a variable name can be something like H1, it can be something like H underscore 1, but it cannot start with a number, so it cannot be 1 underscore H. In general, if you want to name a variable, you should start with an alphabet at least, and then you can add numbers. So you could add numbers and underscores, so you could name it this way. Also, do remember that generally you cannot use asterisk and these characters because they have special meaning in C, so you cannot use these. But for variable names, either use alphabets or numbers, and then the only special character that is allowed is what is called an underscore. Okay, so what does our program do? First thing that it does is it prompts, or it prints a prompting message. So it tells the user enter the first integer. You could think of this as maybe going to any website, let's say your banking website, and it will have some message printed over there. Let's just say enter username or something, and then ask you to input a username. So that's what this prompting message is doing. It is displaying some message so your user knows what to do. I mean, this is not something which is absolutely required. So you could just print the Scanf and ask the user to input variables, but the prompting message is obviously important, or is generally included, because otherwise the user would not know what to do, right? So what this prompt is doing is just saying enter first integer, and then it has \n, which means that take the cursor to the next line. And so on the next line, what you have is your program is waiting for the user to input an integer and using a scan statement. And what does the scanf statement or scanf function look like? What it is it format? So it has two components. First, it has this %d included inside double quotes, and what this is basically what is called the format control string. So %d basically tells the program that it should expect decimal integers in here. So it should expect whole numbers to be input by the user. And then it has a second part which comes after the commas, which first has an ampersand or an and symbol, and then it has the name of the variable which the user is inputting. This variable is called an integer 1. So we first input integer 1, And what do we mean by this and sign or the ampersand? Well, what the ampersand means is that it refers to the memory location of the integer 1 variable. Of course, the reason why you declare an integer initially, so the reason why you have to tell the program that it is going to store an integer is that the program, once it sees this statement, it basically allocates a certain amount of memory for this variable, and a memory location generally, so this will be, to you this looks like integer 1 and you refer to it as integer 1, but for a computer this generally is some sort of memory location which generally is which is generally stored somewhere on its hard disk or on its RAM. So this AND basically tells the computer to, okay, take this decimal integer that the user inputs. So if the user inputs the number 42, it tells the user, okay, it takes this decimal integer and put it at this location. So it goes 42. So it goes ahead and saves it at that particular location. Okay, and so that's why the second argument of the scanf basically begins with an ampersand or an and sign, because it refers to that particular memory location. So your computer then goes to that memory location and stores the number in that location. But even if you don't understand this, we will talk about memory and how it's organized in more detail in later lectures as well. Just need to remember for now, what you need to remember is whenever you use scanf, you need to first have the format identifier followed by a comma sign, followed by this and then followed by the variable name, and then of course the semicolon. So basically what will happen is when the user enters an integer, the first time the user enters an integer number, it will be stored in variable integer 1, and then second time when the user enters an integer after being prompted by the computer, then that value will be stored in integer 2. So basically the printf and the scanf functions allow you to interact with the user, or allow you to easily input and output data to the users of the computer. And the final component of our program, of course, is the assignment part, where what we do is we take integer 1, we take integer 2, we add them up, and then we assign their value to a third integer variable called the AND variable, the sum variable. And finally what we do is we basically take the sum variable, and then we want to output that to the user, and when we want to output that to the user, we use the printf function. And in this case, with the printf function, the only thing that is different from previous programs is this part, where you're again using the format identifier. So you're telling the program, okay, you should be printing, you're going to print decimal integer here, and what is that decimal integer? You separate, after you write the second inverted commas, you basically write a comma, and then you say that this is the sum variable. So that's what you are printing. So what the user will see is sum is, in the previous case, if sum variable was, let's say, equal to 100, then it will be printed sum is 100. Another thing that you could have done is you really did not have to declare the variable sum. You could have actually made things even more simple, or more concise rather, is you could also have added the two integer variables within the printf statement. So this is something which is allowed by C. So what you could also have done is just gone in and written integer 1 plus integer 2, and that would have also done exactly the same thing. Okay, and then one more thing that you probably just want to look at, or I want to briefly mention because I have talked about this already. C language basically stores all the numbers that are input and output into specific memory locations, and so what happens is, when the first scanf line runs and integer 1 is input, what the program does is that it takes the number that is input by the user and it stores it at a certain memory location. Then when the scanf is run the second time, the second value which is entered is stored to integer 2 at the pre-assigned memory location. Now here you get the impression that these two memory locations are next to each other. That is just for illustration purposes. It does not have to be the case. It is possible that integer 1 is stored at a certain memory location. So integer 1 is stored here, and then you have multiple memory locations in between, and integer 2 is stored somewhere down here. So if this is location 1, this is location 2, 3, 4, they don't have to be, let's suppose this is, or not 5, this has to be location n, right? So they don't have to be stored next to each other. You just need to remember this. And then finally, if you're going to add them up and declare another variable, then that value is also going to be stored in any memory location that the program selects when it runs, and that can also be printed later on. So it can be printed using the printf function. Now the next thing that we want to do is basically or introduce is arithmetic in C. So what is arithmetic? Arithmetic would be something like, let's just say if you want to apply some mathematical operations on your numbers, let's say if you wanted to multiply integer 1 and integer 2, then you can do that using the asterisk or asterisk sign. If you want to divide them, you can use the forward slash, and if you just want to add them, you just have to use the plus sign. So it's similar to algebra, with the exception that instead of using an x for multiplication, you're using an asterisk. So do keep that in mind. Here in this table you actually see some examples of this. So if you wanted to add the variable f, you want to add the number 7 to the variable f. In algebra you have to write f plus 7. In C you will first need to declare the variable f and then add to it the number 7. Subtraction is also done similarly. With multiplication, in algebra you just write bm or b times n. With c you have to explicitly put an asterisk between them. If you write bm, it will not know that you want to multiply two variables. In fact, it will consider this as some new variable that it has not seen before. Division is accomplished using a forward slash, and then there's another operation which is called remainder or the modulus operator, and that is generally accomplished using the percentage sign. Here is an example of what we mean by the remainder or the modulation or the modulus operation. So let's just say if you had 7 mod 4, what that would mean is if you divide 7 by 4, what is it that is left behind, and you know that you would have 3 left behind. Now you can use parentheses to actually couple different operations. So let's just say in algebra you wanted to do something like a times b plus c. You can do that with the exception that instead of x you have to use an asterisk, and so let's say you wanted to, and obviously you probably remember from high school that this and this are of course different. A star b plus b basically would mean that a and b are first multiplied and then added to c, whereas in this case you have b and c getting added first and then getting multiplied by a. Another thing that you want to remember is rules of precedence. So which operation takes place first, and the highest priority is given to things that are inside parentheses. Another thing is that sometimes you want to use parentheses not because of arithmetic or mathematical reasons. Sometimes you just want to use the parentheses to improve the readability of your code. For example, over here in this example you could have just written it as a plus b plus c and it would have the same effect, but if you add these two parentheses it kind of makes your code much more readable and easier to maybe understand. So you don't have to always do it due to mathematical reasons. So whenever you are kind of computing or evaluating expressions which have multiple operators, so things like a star b plus c, the highest priority is given to parentheses. So things that are inside the operations that are inside arithmetic or inside parentheses are computed first. So you will first have b plus c. The result of that, let's just say, is 10, and then that will get multiplied to a. So that's what we mean by precedence. Precedence you could also think of this as priority. So what gets the highest priority? Parentheses generally get the highest priority. This is followed by multiplication, division, and remainder. And then next priority is given to addition and subtraction, and then finally it's the arithmetic operator or equal to is evaluated at the very end. That's similar to how things are done in algebra as well. So let's just look at one table. So this table shows you the priority. So parentheses evaluated first, followed by multiplication, division, and remainder. And you have addition, subtraction, and then lowest priority is given to assignment operator. And then another thing that you want to remember is that if you have multiple operations of the same level of precedence, so if you have multiple multiplication operations in your expression, then what the compiler does is it starts from left to right. So it first evaluates the multiplication which is on the which it sees first going from left to right. So of course when it looks at this impression, it also sees addition as well, but addition has lower priority or lower precedence than multiplication. So it first computes this one, 2 times 5, that's 10. Then it takes that 10, it plugs it into the expression, and then it sees, okay, the next one is 10 times 5, which is 50. It takes that, plugs that in. Next it sees an addition. It ignores that because it still has a multiplication. It goes and evaluates that, that's 15. And then finally when it has all additions, it then goes ahead and computes 50 plus 15, which is 65, and then finally 65 plus 7, which is 72. And that's how it operates. And that, I believe, is the end.